Hey there, and welcome. Today, we're going to tackle a really clever number puzzle. We're breaking down a Python algorithm that takes a list of numbers and simplifies it using just one single rule. Now, it sounds simple, but how it handles these little chain reactions, that's where the magic really is. So let's dive in.
All right, so take a look at this list of numbers. The challenge here is to simplify it, to kind of merge these numbers together, but how? What's the rule? What's the logic? Well, that's the puzzle we're going to solve right now.
And you know what? The rule is surprisingly simple. If two numbers next to each other share any factor other than 1, which just means their greatest common divisor isn't 1, you have to merge them. That's it. That is the entire game.
Okay, so to pull this off efficiently, the algorithm really leans on two key tools. Before we actually walk through the solution, let's make sure we're familiar with both of them.
First up, we've got the greatest common divisor, or GCD. All this is the biggest number that can divide into two other numbers perfectly. For our puzzle, this is everything. If the GCD of two numbers is bigger than 1, they merge. It's basically our official factor detector.
And our second tool? That's a data structure called a stack. Honestly, the best way to picture it is like one of those spring-loaded plate dispensers at a cafeteria. You can only put a plate on the top, and you can only take a plate from the top. The last one you put in is always the first one to come out. And that principle, last in, first out, is absolutely key for how this whole thing works.
All right, we've got our tools, we know the rules, we are ready for the main event. Let's walk through our example list, one number at a time, and see exactly how this whole simplification thing happens. So, here's our starting line. We've got our full input list on one side, and on the other, we have our workbench, the stack, and right now, it's totally empty.
We kick things off with the very first number in our list, 6. Now, since the stack is empty, there's nothing to compare it to, right? So the rule is simple. We just put it right onto the stack. Easy enough?
Okay, so after that first step, our stack just has a lonely 6 sitting in it. Now we grab the next number from our list, which is 4. Aha! Now things get interesting. We've got our incoming number, 4, and we need to compare it to the number that's currently on top of our stack, which is 6. The big question is, do they share a factor? So, we run the GCD on 6 and 4, and what do we get? We get 2. And since 2 is definitely bigger than 1, our rule kicks in. These two numbers can't stay separate. That means it's merge time.
So how does this merge actually work? Well, first, we pop the 6 off the stack. Then, we take that 6, multiply it by our current number, 4, and then we divide that by their GCD, which was 2. That leaves us with 12. And this new number, 12, gets pushed right back onto our stack.
Okay, so our stack now just has the number 12. And this is where that chain reaction starts. The next number in our list is 3. We check the GCD of 12 and 3. It's 3, so they merge. We do the math, 12 times 3, divided by 3, and we're left with 12 again. Okay, next up is 2. The GCD of our 12 and the new number 2 is 2, so they merge too. 12 times 2 divided by 2, and we're back to 12. So even after 2 merges, our stack is still just holding that single number, 12.
All right, after all that merging, our stack is holding strong with just the number 12. The next number from our list is 7. So, you know the drill. We ask the question, what is the GCD of 12 and 7?
And guess what? The GCD is just 1. This means 12 and 7 are coprime. They don't share any factors at all besides 1. And that means the merge condition is not met.
So what do we do when that happens? It's actually super simple. No merge means no complicated math. We just take our current number, 7, and we place it right on top of the stack. Okay, so our stack now looks like this. 12 on the bottom, 7 sitting on top. We're on our last number now, 6. We check it against the top of the stack, which is 7. Their GCD is 1, so once again, no merge. We just add the 6 right on top.
So we've seen what happens, but let's take a second to talk about why it works so well. Why is using a stack so clever for this problem? The real magic is all about how it handles those chain reactions. Okay, this right here is where you really see the genius of this whole algorithm. Let's look at a new list, 2, 3, 6. After we process the first two numbers, our stack is 2, 3. Now when the 6 comes along, it merges with the 3 on top and it becomes a new 6. But here's the brilliant part. The code doesn't just stop and move on.
No, there's a while loop that says, hey, wait a minute, since we just made a new number, we have to check it again against what's underneath. So it checks the new 6 against the 2, and they merge again. This little loop is what guarantees that all possible chain reactions are handled correctly, right as they happen. It's just so elegant.
And just like that, we are through the entire list. The algorithm has done its thing. So after all that work, what is the final, simplified version of our original puzzle?
Well, our final answer is simply whatever is left on the stack. The original list, 6, 4, 3, 2, 7, 6, has been completely simplified down to 12, 7, 6. Those first 4 numbers all collapsed into a single value. Pretty cool, right?
So what's the big takeaway here? By using a stack, this algorithm gets to solve a really complex problem in a really simple way. It only ever has to think about 2 things, the new number coming in and the one number right on top of the stack. It's this simple, one-at-a-time focus that lets it handle those crazy cascading merges so elegantly without ever having to look back.
And that kind of leaves us with a cool thought to chew on. This whole one piece at a time approach is just so powerful. It really makes you wonder, right? What other complex problems, maybe in text processing or physics simulations or even game design, could be totally simplified just by using a stack to resolve these chain reactions right as they appear?